delete this one. Yeah, so actually, let me change my theme to light so we can all see what I'm doing. Light plus. Yeah. Good one. Okay. So let's begin. First of all, let me just create a test.js file and get things ready. A little bit. Yeah. Okay. So we're going to be starting with constructors. Well, first of all, we explain what is. As you can see, it's a type of inheritance mechanism in JavaScript where objects can inherit properties and methods directly from other objects. And a constructor here is simply a function that is used with a new keyword to create an object. When you create a constructor, you can create instances on that constructor because objects are created by reference and not by value. So when you create a constructor, you can easily reference other objects and that constructor. And creating a constructor is very simple, and you can easily create a constructor using a function keyword. But what distinguishes a constructor from other functions is the name starts with a capital letter. Let's say you want to create a constructor, a car constructor, you start with a function car. You can see the name is capitalized, and like this. This is simply a constructor function. And if you want to reference an object on this constructor function, you simply create, let's say, const car1 is equal to new car. And don't forget to include this new keyword because the new keyword determines the reference the constructor function is returning. But without this new keyword, the reference is completely lost and it will return a global object, not knowing exactly what you are referencing. So this new keyword is very, very important. And let's say we want to create a car object with the car name and the year the car was produced in. You just pass in let's say the car name and the year. Then we try to initialize those the name and the year in the constructor function. So we say this dot name is equal to name, and this dot year is equal to year. Sorry. This dot name is equal to name, and this year is equal to year. So notice the use of this keyword. This keyword is not directly referring to the constructor function. It's referring to the instance created on the constructor function. This keyword is referring to this car1. And if you create another instance, let's say const car2 is equal to new car. Now, this keyword, when you create a new instance, this keyword is automatically referring to that new instance you've created. Now, let's say we passed in a car name of let's say Golf, and we pass in a year of 2020. This car, which is Golf. So this keyword here, you can create many instances referring to this, referencing this constructor function as many instances as you can create. You can add car2, like car2 is equal to new car. And you can pass in, let's say, Toyota. Toyota 2022. And you can try to, let's access the Toyota year, car2 dot year. And you see 2022. And the reason why this is happening is because objects are created by reference and not by value. So this reference is pointing to the to this object in memory. The car1 is pointing to the address holding this object in memory, and the car2 is also pointing to the pointer holding this object in memory. So you can create as many instances as you wish to create, and it will still work. Now, we may like to check if, let's check if car1 is an instance of the car constructor function. Or let's say, let's check if the car1 is an instance of this car object. Let's say if you want to check that, let's say car1 is instance of car. Now we try to log it to the console to see if it's returning true. Yes, actually, because the car1 is an instance of the car object. But if you create another constructor function, let's say function person, now you pass in a name, you say this name is equal to name, and you try to check if the car1 is an instance of the person function, it will definitely return false, because here car1 is not an instance of the person object. You see that it's returning false. So instances are created directly on objects. Like this car1 now, it's created on this object of the car object, but not the person object. So if you try to check the instance of the car1, it will return the car object, but not the person object. And you can add methods to these objects. You can add values, you can add methods, and all of that. Any method you add to these objects can be accessed in any instance created on it. Like if you add any method to this object, car1 can access it, and car2 can access it. Let's say we want to add a method that outputs the year the car was created in and the name of the car. Let's say we'll add display details. And this will simply be a function that logs the year, and the name and the year. Get identified. Sorry, I'm getting an error. Sorry, this is supposed to be an equal sign. Sorry, that's really so this method here can be accessed on this this car1 and can be accessed in car2, because car1 is referencing this car object and car2 is also referencing the car object. So let's say we want to access this display details on car2 dot display details, and now we run it. So car2 dot display details is not a function. Actually getting an error. What's happening? Tableau. Okay. This not a function. Sorry, I forgot to add a this keyword here. Yes. This dot display details is equal to function log this dot name, this dot year, and we'll log it to the console. We get Toyota 2022. We can add more and say name is, and it was produced in the year. This that year. We run it again. You see. Okay. Said, go ahead. Any questions? Said, I can see you raised your hand. I thought you guys.
Okay, sir. Thank you, sir. So instead of saying this dot display details is equal to function, can we say display detail? Just display detail and
no, when you say when you say display details, you actually get an error, because when you reference this keyword, you're actually referring to this car. So we have two instances here, and when you use the this keyword and you create an instance, the this keyword now is referring to this car1. And when you say car2 dot display details, I mean this keyword is not referring to this car2, but not car1. But when you don't make use of this keyword, you get an error, because the constructor doesn't know the reference you're actually referring to. You understand?
Okay, so I'm just thinking maybe if we remove the equal and function, the equal sign and function, just display details. So that's what I'm actually.
No, the function is actually a method. It's returning this. It's actually performing its function. If you remove this, okay, you want to remove this?
No, just equal and function keyword.
Okay, like this.
You can, yes, I just think maybe if you remove the equal sign and function keyword, just function keyword, then we leave the other.
Okay, you mean something like this?
And display this.
Okay, then display details.
Yes, without using function keyword.
No, that won't work, because we are trying to, you are making use of this. This keyword is very important in constructors. Yes.
Okay. Thank you.
We are trying to tell the constructor that this reference here, that this keyword is referred to car1, and when you call car1 that display and details, the constructor will know that yes, you are referring to car1. So what are you passing to car1? You are passing golf and 2023. Then it will get access to the golf and the 2023 and return it and display it for you, and you get to do what you are trying to do with it. But without using this keyword, the constructor function will not actually know the reference you're actually trying to access. You understand? Okay. So that makes the this keyword very important. The this keyword is not actually referring to this constructor function, but referring to these references created from this constructor function. And you can actually add methods and do other things with this constructor function here. You can just pass in a name. Let's say you pass in a name, and you can add properties like the accessor. We have the data properties and the accessor properties. So you may want to make your object more defined by adding accessor properties by passing in, you pass in this name, and then you can call the global object and define a property on this constructor by saying objects that are defined property. Then you pass in this keyword. By this keyword, you are referring to the instance that will be created, the instances that will be created. Let's say we create an instance of car1, then this keyword here is referring to this car1, but not actually the constructor function. And after this keyword, you pass in the property you are trying to define. And this property here is the name. We pass it in a string form, the name property. And then we actually pass in the object literal, pass in an object literal. And inside this object literal, we define the kind of properties we want. And let's say we want a property or a method that will return the car name. We just give it a get. This get keyword is very special. It's a special keyword. Then you give it a get, then you write your own function that will return the car name function. Then you simply return name. Now here, you don't need to use this dot name because you are already referencing this here. This means this instance here you are creating on this constructor. So you don't need to use this here. You simply need to write your function and return the car name. And you can also write a method that sets the car name. And this set method here takes a function. This function takes in a parameter that will later be passed a value that will be set as the car name. You can just pass in a parameter of new name. And inside this new name, then you can just set the name to the new name. You can just say name is equal to new name. And you can add more properties. You can configure your objects how you want it to behave. You can add a numerable, true, true, and configurable to also true. Now you can try to access your card, give it a new name. Now you try to check your card name, dot name. This will give you, we output gov on the console, but then you also set a new name. See, something like car1 dot, you call the property set, the property set name. You call on like you want to set a new name, you just call car1 dot set. Then you pass in the kind of name you want to set to the new car, and the name will automatically change to the new name you want to pass in. And you can actually check the properties this constructor has, its own properties, and the properties it's inherited from the global object property. Like it has its own prototype and it inherits some methods from the global object prototypes. So we can check the objects that it itself has and the ones it inherits from its global object prototype. Let's say we want to check the name. You see, log name in car1 returns true because the name property is actually in this card because we've added the name here and we've defined this property name and we added some methods to the name. But if we try to check log, does the car1 has own property. And we're passing the property of check if it has its own property. If it has this property, it will return false because this property is a global object property and it's inheriting from the global object. So if you try to check like has on log has on property in car1, it will actually return true. But if you try to check car1 dot has on property, it will return false because this property is not actually this function's property. It's inheriting it from the global object property. Now, if you try to check, let's say the global object, let's say the object is equal to object dot prototype. Now, if you try to check if the global object has this property, it will return true. Object dot has on property has on property. It will actually return true because this property is a global object property and this constructor function is actually inheriting it from the global object property and using it. But when you try to check the name is actually the car property. It's not inheriting it from the global object. It's actually the constructor's property. So if you car that has own property name, it will return true. The has own property property is in car, but it's not actually its own property. It's the global object property that it's inheriting from. So if you try to check if it's its own property, it will return false. So that's how constructors work, and that's how they have been defined and declared. Now, the prototype property, actually an instance keeps track of its prototype through an internal property called the prototype. So this property is a pointer back to the prototype object that the instance is using. When you create a new object using the new keywords, you know, the constructor's prototype property is assigned to the prototype. And the property of the new object is actually referencing the original prototype in which it inherits from. What the whole grammar we're speaking here is, let's for instance say, let an object equal to an empty object. Let's say obj is equal to an empty object. Now, let's say let's proto equal we just created. Now we want to check if the prototype of this object we just created is equal to the global object prototype. Then we can say log log proto is exactly equal to object dot prototype. Now we're trying to check if the prototype of this object we just created is equal to the global object prototype, and it will return true because the prototype of this object we created is the prototype of the global object. It's inherits from the global object prototype. So how inheritance work is the objects the global the properties the global object has, this object will inherit and use, except you add new prototype a method called toString. So let's try to log the toString method on the console. Object dot toString. It's actually returning an object. That is an object. This method is inherited from the global object. So it's returning an object. And you can try to like redefine this method. You can try to say object dot toString is equal to a function. And all you want this function to do is to return, let's say you want it to simply return an object or any name, let's say custom name. Now, when you call this function now, instead of it returning this object, it will return the method. Oh, sorry. Instead of it returning, it's supposed to return object to string is equal to function. Supposed to return this custom name and not the object. Any errors in our code? Let's check it out. It was a mistake. I did not save the file. So it returns the object and custom name instead of returning. Let's try to comment this out and check it again. Log it to the console, it will return the object. And this toString method here is an object actually inherited from the global object. So that's why it's returning an object. Now we've redefined this toString method and we've removed this object and added the custom name, which is inherited also from the global object property, but we've modified it and added method inherited from the global object property. You can make it anyhow we want it to be. And we can also change their values, how they behave, and all of that. Next, we've learned about prototypes, how objects inherit. Using prototypes with constructors is simply combining constructors with prototypes and adding methods and data types and accessor types, how you modify your objects, how you want them to behave, and all of that. So we can create a simple object here. Let's say car, we pass in a name, and we say this name is equal to name. And with this, we may want to add a method to this car prototype. You know, the prototype is the initial object where other objects can inherit from. So we may have two instances. Let's say we have car1 is equal to new car. Then we pass in a name of golf. And we have car2 is equal to new car. And we pass in a name of, let's say, Honda. Now let's access the first car's name. Okay. The first car's name. It outputs golf. But then we want to add a method to the global, the car object. We want to add a method to its prototype so that this reference can be able to access it, and the second car reference also can be able to access it. So what we're going to do is we're going to simply say car.prototype, and then we'll specify the name of the method we want to add. Let's say we actually want to access the car name with more information. Or let's say display details. Then we assign it to a function. It's simply a function that displays the car's name. Then we say log this name. And actually, always remember that this here is not referring to this object, it's referring actually to the reference. So when we call car1.display, display details, this keyword is referring to car1, because display the car1 details, and the car1 details we have the car name as golf, so it will simply display golf on the console. Oops, and it's returning undefined. Okay, we're not supposed to log it on the console because it's already logged. So we're simply supposed to just call the function, and it will display golf. We can actually say the car's name is, and we concatenate it with the car's name. Then we display it. The car's name is golf. And look at what is happening here. The second instance can also access this method because it is defined on the prototype of this car object. So we can simply say car2.display details, and the details will also be displayed on this second car. The car's name is Honda. And we can add different methods. We can add another method like car.prototype. You can see we are calling the prototype because we are adding this method to this object prototype, not the instances, so that all the instances can be able to access the method we are adding on the prototype. So we can actually say car.prototype. We can actually add a year here and say this year is equal to year. Then we can equally come down here and say car.prototype.display full details. Then we'll assign it to a function, and this function will simply log this name and the year to the console. Now, if you call the first car to display full details, and the second car to also display the full details, what will we get? Sorry, okay, not passing in the year here, 2023, and we'll pass in the year 2022. And then we log it to the console. We're getting golf 2023 and Honda 2022. Because this method is defined on the car object prototype so that other instances can access it. And it's another way of doing this. Instead of always writing car.prototype, what we can just do is we can just come here and we can say car.prototype is equal to, that's we're assigning an object literal on this prototype, on this car prototype. Instead of writing car.prototype, we just add in all the methods here, and we say display details. Instead of adding saying car.prototype, we just come here and say display details. Then this is an object, so we have to make it key value pairs. So the key here is display details, and the value we give it a function that logs we'll give it a function that actually logs the car's name. This dot name. We're actually getting an error. So what's the error saying? Using statement. Okay. Function say name. Split this. CO2 function. Okay. Oops. Syntax error. Okay, Josh, can go ahead, Josh.
Yeah, I wanted to say that the function is not spelled correctly. The function keyword.
Oh, thank you. Actually, mistake from me. Sorry about that. Thank you about that. Now we've added a method to directly to the car prototype, and we can also add another method here, like display year. We're taking a function that simply displays the year on the screen. Then we try to call car1.display details. Then we take in car2 that displays the year. Then we check it out. We still see that it's still working. But there's a problem with this method here. The actual problem here is, said it's actually the same as using the bind, the call, bind, and the apply method. But actually, we're not going to talk about the call, the bind, and the apply method because we can use those with object literals and using the data methods and the apply method on object literals. We're not going to talk about those in these constructors and prototypes. Thank you for that. Actually, there's a problem with this. When we try to check if the object constructor, now we've overwritten the card constructor because we're now referencing the global object constructor, not the card constructor again. So we'll try to check if the object is actually the card constructor, it will return false. Now let's check it out. Let's for instance, we want to check log. Let's create an instance. Because car1 is equal to new car. Then we pass in the name of golf. Then we try to check if car1 is an instance of a car. It will return true because it's actually an instance of car. As you can see, it's an instance of car. But if we try to check if the constructor car1.constructor is exactly equal to, if we try to compare it to the card constructor, now it's returning false because we've overwritten the card constructor. We're referencing the global object constructor now. Now, in order to solve this problem, we have to come here and the first thing we'll specify the constructor to the car's constructor, and this problem is solved. So if you want to use this method without calling car.prototype.method name every time, and you want to simply use this method to add all your methods and values, you simply come here and specify the car's constructor here instead of always calling car.constructor. Now, if you check, it returns, still returning false, please. car.prototype, the constructor is car. It's not supposed to return false. Okay. Actually, let's check it again. What is it returning false? Because I've specified the constructor here. The car prototype. Okay. Okay, so let's see what's happening because it's supposed to return true. Car constructor, car1 constructor is equal to car1 dot constructor is equal to the global object. Let's check if it returns true. It's returning false, and this is also returning false. So we have car, we have the car, the prototype. We've added methods, and let's change this, comment this back. Test it out. True. Car1 is an instance of car, but the car1, the constructor, is not the constructor of car, and it's not the constructor of the global object. And why is that so? Okay, let's try to move this here. Check it out. It's still returning false, and I don't know why, because it's supposed to return true because we specified the constructor here and the line 16. Okay. Constructor. Oh. Thank you. Oh, typo error. Thank you about that. Thank you. And it's now returning true because the constructor of the car1 is the car, and the constructor of the car1 is not the global object. So if we change this, we comment this out and then try to run it again, you can see that here it's returning false because now we've overwritten the car's constructor to the global object, and the global of the is now referencing the constructor of the global object and not of the car object. So this is how this problem is solved. First of all, if you want to specify more than one method and want to make it simple, you just come here and you first of all specify your car constructor in order not to forget, because in managing complex code and complex objects where we have millions of constructor functions and millions of instances, where you create instances and reference them, if you don't specify this, you get errors in your code, and your code you break and you may not know why. And in non-strict mode, it will fail in silent, but if you specify the strict mode, you will get an error. So you have to be careful about specifying the constructor when you're adding prototypes this way. And next, we're going to be looking at built-in object prototypes. Every function has prototypes, has built-in prototypes that can be inherited from. Now, when you create new functions, it automatically access the method from the function's prototype, from the original prototype. Like, you might be wondering if prototype allow you to modify the built-in object that comes standard in JavaScript engine. Yes, you can modify it. You can modify the object, the built-in objects of the JavaScript method, like the array method, the string method, and all of that. They have prototype that can be changed. You can add new methods to it and then modify other methods. Without talking too much, let's dive into examples. Like, you want to add a new method to, let's say you want to add a new method to the array. you are simply working on your code and you want to add a sum method that when you apply it on the array, it simply sums all the elements in the array. Simply, the array, you call the array.prototype. As we earlier did, we added methods to the car prototype. You can actually add method to the array prototype. Now you call the array.prototype, then you add the method you want. You can see other methods here. Once you call the array.prototype, all these are built on the array prototype: the shift, the slice, the sum, the concat, the couple within the entries, and all of that. So you can actually add your own method. Let's say we want to add a method of sum that sums all the elements of an array. We can actually say it's equal to a function that actually returns this dot reduce. A reduce is a higher order function that takes in a callback function. Then you specify the previous value and the next value. Then you actually return. What you want to do is you say the previous value plus the next value in the array. Now, let's say we have an array of numbers and we want to sum them up: 1, 2, 3, 4, 5, and so on. Then we can simply say the array of numbers dot sum, the method we've just created. Then let's try to run it, and we'll see 15, because 1 plus 3 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 plus 5 is 15. So you can actually modify built-in prototypes. We've modified this. We've added the method to the array prototype, and we can also add another method to the string prototype and others. We can actually add a method to the string prototype that capitalize a name, any name that it's passed in. Let's say we want to add a method to the string prototype that capitalize any name that is passed in. We can simply say string.prototype that capitalize. Notice the names here. The array here is capitalized also, and the string is capitalized because they are built-in prototypes we want to inherit from. We want to inherit from the string and then add new methods to it. So we can actually say string.prototype that capitalize is equal to function, and this function will actually return this dot there's a character, the first character, the character at 0. Now we'll call the character at 0, and what we want to do with the character at 0, we want to make it an uppercase character. Then we want to concatenate it with the remaining characters of that word. What we're actually doing is we want to concatenate it with the remaining characters of the word, and the remaining character starts at 1. Actually, let's comment this out and see how the substring work. Let's say we have a string of name is equal to Chris. Then if you say log name dot sub string 1, we actually get HRIS instead, because the C has been removed. So what we are trying to say in this code here, we've removed the first character and capitalize it. Then we will concatenate it with the remaining characters. Now, if you have a name of, let's say, const name is equal to Chris, and want to capitalize it, we'll simply say name dot capitalize, and then we log to the console to see what we've got here. You can see that it's working. So we can actually add new method to the inbuilt methods of the array prototype, the string prototype, and all of that, the function prototype, anyhow you want your code to work, and all of that. But keep it in mind while doing all these things that objects are very, very tricky. When dealing with objects, you have to be very, very careful in order not to make certain mistakes. So you can actually specify, you can even add other methods like divide, multiply, or anyhow you want your code to like behave, something like that. And it will actually work. Adding methods to inbuilt prototype, but that is not, you shouldn't make that a behavior. You shouldn't be doing that always, because it's not good. It's not always good to add methods to the inbuilt prototypes. It's always good to create your own constructors and then add methods to it and then use it in your code, rather than creating prototypes on the inbuilt functions and methods of JavaScript. It's not that good. Okay, so now let's move over to inheritance. We've talked about prototypes and constructors, built-in object prototypes, and now we are going to be talking about inheritance. Now, how does inheritance work? Inheritance is simply the simplest form of inheritance between objects. All you have to do is specify what object should be the new object prototype. Like you have an object and you want to inherit from that object. You want to inherit from the methods or the data or all of that. So all you need to do is specify the object prototype. Let's say, for instance, you have an object here. Let's say you have its object is equal to an empty object, and or let's say you give it a name. Give it a name of empty. You give it a name of an empty object. Then, or let's say title. Let's make it a title. Then you say the title is unknown. Then you want to create a book that will actually inherit from this object, this first object here. So what you just say is let book is equal to object dot create, and then the first thing you specify is the object you want to inherit from. And at this point, let's say we just want to inherit from the group, from the global object. Let's say we want to inherit from, let's specify the global object. So the global object prototype is the object dot prototype. We want to inherit from the global object prototype. Now, the next thing is the object we want to inherit those properties and apply them to. So we specify in an object literal, then we give it a title, then we specify all the properties we want. We give it a title here. Now, note that if you don't specify all these methods and properties, they won't work. Properties like enumerable, configurable, and all of that, you will have to specify it if you are declaring your objects like this. So you have to first of all pass in configurable to true, enumerable to also true, and then the title, specify writable to true. Then you give it a title of old book. Now, actually, you've inherited the properties instead of creating this book like this. let's make it clear. This is what JavaScript engine does for us. When you create an object like this, an object literal, like let object is equal to, or let's make it more clearer by specifying, making it a book also. So when you say let book is equal to an object literal with a title of old book, this is what JavaScript does. It creates this object, then inherits from the global object prototype, and then adds the method to this book. Now, if you try to check if this book is enumerable, you can simply say log book dot is enumerable. Now log it to the console. Sorry, book has already been declared. Oh, let's comment this out. Maybe it's not a function. Enumerable is not function. Actually, an error. So code. Okay. 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 So, sorry, what I'm about checking is if book is an instance. Book is instance. It's instance of instance of object, the global object. I get still getting error, sorry. Book. Book. And where am I still getting an error here? Sorry about that. I want to actually get the prototype, not the instance. I want to actually get the prototype. So let's say book dot let result is equal to object dot get prototype of a book. Now we want to get the prototype and then compare it to the global object prototype. Now let's compare it to the global object prototype. Result is equal to object dot prototype, and let's see what we get. Yes, and it's returning true because we are actually inheriting from the global object. And now let's say what we have here is let's say we have a car, and then inside this object we now specify the car, or not the global object, and then we try to see if the prototype of this object book here is inherited from the global object. We're having false because this is actually inherited from the car, but not the global object. Now let's try to get the car's the book's name. There's no way a car and a book are related, and there's no way you may want to inherit a book from a car, but this is just for instance. So let's try to get the book title. Log book dot title, and let's see what it's logging undefined actually. Login undefined, and the reason why is because here it's supposed to be value and not title. That's a mistake from me. Value, old book, and it's returning old book. Let's make this a new book. It's running old book, And then let's omit this value and then try to see what it brings. It's returning undefined because the value is not specified. But if we've inherited this method from here, and let's say we have a display details that actually is a function that logs the title on the console. And then we actually say book dot display details. And let's see what we've got. It's, oops, still returning undefined, but we are inheriting from the car. And that may be an error. Okay, I'm sorry about that. Constructor inheritance doesn't work this way. It actually escaped my mind. It doesn't work this way. In this method will not actually work here, but this object is actually inheriting from this car object, but the method will not work here. For the method to work here, we actually, let's say we've got an object of a car with a name. And then we specify the name. And we want to actually inherit from this car. We want to say, let's add a method. Let's say car that prototype that display name is equal to a function that actually returns the logs the name on the console. So it actually logs the name on the console. That name. And then we actually want to let's say the year also, or the name and the model. Let's say the model, and this model is equal to model. Mistake, and we'll actually want to display the model, the name, and the model. And then we have another constructor function. Like we have, this is an object, and we have another object of new car that actually takes in the, let's say, the brand. That actually takes it only the brand. Now we just say this dot name is equal to brand, and this dot size is equal to also the brand. Then we want to inherit, the name and the size actually coming from the car object, and we want to inherit it from the car object. So what we're actually going to do here is we're going to say the new car dot prototype is equal to the new car actually. We're saying the prototype is of the new car, sorry. The car prototype, the original car, not the new car. We're actually saying the prototype of this new car should be should come from this car. And the constructor, the new car, the constructor should be the constructor of this new car, but not of the main car. Now we say new car dot constructor dot prototype dot constructor is equal to new is equal to new car, like this. And now, let's try to access this method like const new car1 is equal to new car. Then we pass in a brand of, let's just say Toyota is a brand or something like that. Then we try to access new car1 dot display name. Let's see what happens. Toyota undefined and Toyota undefined. Okay. Actually, we are not passing in anything, but we're inheriting from model car, new car. 2023. Still undefined. Okay. This dot brand. Oops. We're still getting a cably. And what's happening here? Because we're having a car model and we're specifying a method on the car, which is display name. And we are specifying okay. Now we pass in on 2023 and a new car we pass in golf. Okay. And we're still getting undefined. Why are we getting undefined? Why are we getting undefined? Okay, const car1 is equal to new car. Then we pass in a name of a golf and a year of 2023. Let's eliminate this and this. And then let's try to access it and see again. It's still returning undefined. Okay, let me cross-check my code. I have a model here, a car object with a name and a model. Then I have an object here that actually displays the brand. And this should be name and year. Okay. Toyota undefined. New car. Toyota undefined. The last one here is returning undefined. The new car. They're supposed to, the new car, the prototype is equal to new car. And the new car, the prototype, the constructor is the new car. And what else? We're not supposed to be getting an error. Okay. Undefined. Actually, the Toyota here is returning, but then the brand, it's not equal to car, new car, inherit. And let's debug this together. The new car, the prototype is the car it's inherit from. The new car, the prototype, the constructor is the new car's constructor. Then this car is coming from the new car. And let's say car1.display name is returning golf, but then it's not returning the year. It's model, not year, model. Golf 2023. And this is actually working. And we're not supposed to log it to the console because the second value will return undefined. Golf 2023. And let's reference the second car. That is the new car one.display name. It's actually returning Toyota and undefined. Yes, Toyota and undefined because Toyota and undefined. But actually, this dot size stop model, not size. And we've successfully debugged our code and it's now working. It was actually a typo error from me. Now, what's happening here is we've had an initial object with a name and a model. Then we've added a method to the prototype, which is display name. And this display name simply displays the name and the model. Now we have a new car that simply takes in a brand, but we're actually initializing the name of the car to the brand and the model also to the brand. Now we want to inherit this new car. We want to inherit these properties from this car. We want to inherit the properties of this car and add it to this new car. Now we want to set the prototype of this new car to the old car so that it inherits the methods on the old car's prototype. Then here for the constructor, we actually want the constructor to be of this new car. So we set the constructor to this new car's constructor, which is the name, the brand, the name and the model is being assigned to the brand. So now if you call the new car and we pass in the Golf and 2023, it will actually return Golf, this is car one, that display name will return Golf and 2023. But here, if we pass 2022 and we run it again, it's actually returning Toyota and Toyota because we are assigning the brand to the name and the brand to the model. And now we are passing in a year, which is assigned to the model year. Here is returning Golf and 2023 because the initial object here is supposed to return the name and the model, but it's a mistake for me because a model has nothing to do with the year, but I'm actually passing in a year here, returning the year and the name of the car. And this second function here, we are taking in the brand and then modifying the initial object to actually assign the brand to the name and the brand to the model. So here, if you pass in Toyota, this Toyota argument to be assigned to the name and the model. Then if we log it to the console, we get Toyota and Toyota. So that's how simply inheritance works. Simply, if you want to inherit this object, and you can actually add another method here. It's a car.prototype shout is equal to function and then log shout or something like that. Shout. Then you try to access new car and shout. It will display shout. You have to shout for it because you are defining this method on the initial car object prototype, and you can access it on any instance, even on the inherited object. Yes, Josh, someone raised his hand. You can go ahead. Can hear you.
Okay, yeah. I still don't understand this line 22. You know, you set just the brand property brand variable to this.name and this.model. So
Yes.
how do you make the model also display? Because since you are passing just one argument.
Okay, let me answer your question. Now let me reference the second object, the new car. I'm now referencing the new car here with the brand of Toyota, right? Now let's try to display it on the console. We're having, let me eliminate this method so we don't then eliminate also this one. And then try to output this. We're having Toyota. Now let's say inheriting this, we want to inherit we've created a new object and we want to inherit from the initial car object and we pass in a year. So this year now we want to assign the model to the year and not the brand. Now, if you pass in a year here of 2023, this will not output Toyota again, but we output Toyota and 2023. Are you clear with it now?
Yes, I understand this now.
Okay. So that's how basically inheritance works. And you can actually create another one. Okay, Said, you can go ahead.
Okay, thank you. Please, can we define a new properties or method inside the new car function constructor?
Yes. Actually, what you can do is you can say new car dot prototype that this, let's say name, the same name is equal to function, and then you log actually brand, because we are passing in the brand. You log the brands on the console. Then you come here and you access your new car dot say name. Then you log it to the console. Oops, getting an error. Say name is not a function. New car dot prototype dot say name. Oops. I'm getting an error. New car dot prototype dot say name. This question one is the brand. I'm actually receiving an error on what is happening. The say name is not a function. Okay. And let's see what's
Or is it before we have override it on line 19?
okay. Actually, the problem is from me. Thank you for that. Overwritten on line 19, and you're supposed to place it down here. Undefined. New casting. Yes, Said, you can go ahead.
Okay, I'm sorry, I don't understand this overriding you did. Well, this line 16, new car.prototype.constructor is set to new car again. I don't understand it.
Yes, because if you don't set the prototype to the new car, you will get an error. Actually, the thing here is when you inherit from this car, now you want the prototypes to come from this car. You want to inherit all the methods from this car. Then you can add new ones to this one. And then, but you want the constructor to be of this function, not of this one, not of this object. So if you don't specify the constructor to this, you don't assign it to this object, it will bring back the constructor of this, and that's not the behavior you want.
Okay.
Right now, what we are doing, we want the constructor of this new car to be of this one, now not of the initial one it's inherited from. So you have to specify it manually. If you don't specify it, the constructor will actually come from the one you inherited from and not from this one.
Okay, I get it. Please, I noticed that like most of the solutions, most of the workings you're doing, like most of you are rubbing them off. Is there any way we could get like these codes that you are taking us, maybe posted on GitHub or something? Some of us may want to test it out.
Okay, so I will have to take permission from my boss, and I will get back to you if that is possible, if I can host some code samples for you on GitHub so you can access and play around with it.
Okay, thanks.
And in order to move forward, in review, we've looked at constructors, prototypes with constructors, built-in object prototypes, inheritance, and all of that. And inheritance is helpful if you want to build products for other programmers. You want to build something like a piece, and from there you want to inherit from that piece and then build another thing on top of that piece. That's where inheritance comes in. You don't want to go back and start building from scratch. You just want to inherit from what you've already built and then build on top of that and then share it with the people you want to share with. Now we don't have much time. Let's move to functional programming and then brush over functional programming and then call it a day. And in functional programming, as you can see, functional programming is a programming paradigm that emphasizes writing programs using pure functions and avoiding mutable data and side effects. And in functional programming, the first thing we're going to be looking at is pure functions. A pure function in JavaScript is a function that always produces the same output for the same inputs and doesn't cause any like observable side effect. Like in other words, its behavior is solely determined on its input parameters and doesn't modify any external state or have any hidden interactions. In pure functions, for example, let's say for a pure function, a function like function add a, b, return a plus b. Now, if you call this function anywhere and passing arguments, your result will always be the same. If you like passing 10 and 20 to return 30, this is a pure function, no side effects, no observable side effects, actually, because there may be side effects sometimes you may not observe it. But in a case where you write a function where it takes in a parameter of n, then you write something like return n multiplied by math dot random, something like that. Actually, this is not a pure function, and this has some implications, like it's hard to test and you cannot predict the function's outcome. So you can't actually test this function. And now we pass in a value of 2, an argument of 2. And each time we try to get the result, we're getting a different result altogether because we're multiplying these 2 by a random number of which we don't know the value. So that's the problem with pure and impure functions. And avoiding writing impure functions. Let's say, for instance, you have a function that takes in an array and sorts the array. Let's say function sorts, then it takes in an array, then it simply sorts the array. Then instead of saying return array dot sort, something like this, then you take in a higher order function a, b, then you return a minus b, something like this. This is not advisable. Then if you log this to the console and then you say your array is, you have numbers 1, 6, 4, 3, and all of that, and you want to sort this, then you say sort array, then you log it to the console. Actually, this is sorted, but then this function is not pure because you are modifying the original array. You are modifying the original array. You don't have to do that. You have to just copy the array. You can just copy the array and pass it in and then perform your operation. As you can see, if you try to log this to the console, and it still works. But then you can actually say something like, let's old array is equal to the array you are passing in, and let the new array equal to the one you are processing. Something like this. Something like this. Then you want to return an object that contains the old array and the new array. And let's log this to the console. And you can see the old array is unmodified and the new array is modified. This is actually the experience you want. You don't want to modify arrays. You don't want to mutate objects or modify things. You just want to copy them and then perform operations on them, keeping the initial ones intact. So that's where functional programming comes in. You don't want to play around with all this and then mess up things. Okay, for instance, you want to take in, for instance, another example, you take in an array and then you want to multiply all the numbers in that array by 2. You don't have to come in and write a for loop or modify directly this array. All you need to do is a map function actually creates another array with the given array. It copies that array and then creates another array with it. Then you can simply return a map function that this array will map and then take in a higher order function of, let's say, none. Then you just multiply the number by 2, return. So what is happening here is this map takes in an array, then copies that array to another one, then modifies the copied array, not the initial one. So if you log this to the console, what you will get is 2, 12, 8, 4, 6. Every number is doubled. But mind you, if you still, this array is not modified. The initial array is not modified. So you can see it's intact. The map just copied the initial array, copied it to a separate environment, performed operations on it without modifying the initial array. So that is the experience you want. Then ensuring immutability. We're already talking about immutability. You don't want to mutate data. Immutability in JavaScript refers to the concept of not modifying data directly. Instead of changing existing values, you create new values. Yes, you create new values with the changes you want, that is the desired changes. This practice helps prevent an unintended side effect, like the side effects you don't want them to occur. It helps prevent them, and it enhances predictability, like what I earlier said, like you predict your code, the outcome of your code, and then support functional principles. Yes, it also supports functional principles. And here, immutability here, it has something simple that, but if you're not careful with it, you actually not know what you are doing. Let's say you want to modify a value. Let's say you have a value of 5, and you actually want to create a new value. Let's say new number is equal to number plus 3. Yes. Then you log both your number and new number. And this is sweet because you are not modifying the initial value. You're having your 5 and 8 respectively. And this is the kind of seamless experience you want to have. You don't want to modify values. You don't want to tamper with things. You don't want your code to break or like misbehave. That's why those of you that have done React, immutability is highly advisable in React. And in React, you don't modify values. You don't mutate values. You have to copy every value before changing it. Let's say, for instance, you want to actually work on an array. You have an array, the original array of 1, 2, 3, 4 values, ranging from 1 to 4. Then you want to make a new array and then add items to it. Then you can simply concatenate using the concat function, or you can use the spread operator. You can see the const new array is equal to, you create your new array, you spread the old array inside, then you add your values like 2, let's say 7, 3, 4, and 5. So like so, and then you try to log this to the console, new array, and you still get your array back. Still get your value, the new array, and then you should log the old array to the console. The old array, you see it's still intact. The old array 1, 2, 3, 4, 1, 2, 3, 4, and the new array is 1, 2, 3, 4, 7, 3, 4. Yes, and your code is still working as expected. You don't want to break changes. You don't want to mutate values. You only want to copy them and then make changes to it. And for objects, you can also apply immutability to objects. Let's say, for instance, you have an object literal of a person with a name of a Josh and age of 30. And actually, you want to change the age to 25. What you say is const new person is equal to this new object. Then you spread the old object, and then you change the value you want to change. And here you want to change the age to 25. Now the old object is intact, but we've created a new object and modified one of the values of the old object. Now, if you try to log this to the console, we get new person. Now we have Josh and we have age of 25. We've modified this value without touching the old object. And this is what we really want. And you can also, don't do something like this. Avoid doing something like, okay, age 25 and then spreading something like this. No, it will not work. You are still having the age of 30. Actually, what you're doing here is you've changed the position of the age and the name. But after changing the position, spreading this, the age 30 will still override the age of 25. So we have to spread this before specifying the value we want to change, and this will take effect. Yes, and that is how we avoid mutability in objects. And another method is using objects.assign. So we have an object of person with a name of Josh and age of 30. And we want to create a new one because new person is equal to the global object dot assign. Now we want to assign it to a new empty object literal. And then which object do we want to copy values from? We want to actually copy values from the person object. And then which value do we want to modify? We want to modify the age. the age here, we want to modify it, we want to change it to 25. Now, if you log new person on the console, you'll be having the old object with the age changed to 25. And now this is super handy. You can actually say this cons person 2 is equal to something like this. And then here is 29. And this is the this is person 2. Now you want to assign the first person to person 2, but you want to modify this age. Then you come here, you run it, you see that, let's say the second person's name is Ikes, and then you want to actually copy the first person's value to the second person, but you want to change the name and the age also. Then you just run your code. What you are having here, oops, sorry, let's save the code. And we have not changed the name. Okay, we only want to change the age, but not the name. Or if you want to change the name, you can actually say something like, you can actually specify the name here. Name, and the name you want to change, blah, 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 and something like that. And you can see that it will take effect here. And you can see the name SKKSD and the age is 25. And that's how it works. And actually here it can also be an object of person 3. And you come here and specify your const person 3 is equal to the name of unknown and the age of 35. And then you run your code. You can see that it copied this object to this one, but actually modified that. And you can actually add an ID of 20. I can see that you have an ID of 20, but the name is modified and the age is also modified, but the ID is remaining 20 because you copied this object to this one, and then you change the values, you change the name and the age values, leaving the ID intact. So that's how immutability works with objects and all of that. You've got to understand that now. You can use other library like ima.js to avoid immutability, and other libraries, NodeJS libraries, but I think I love working with plain JS without using any libraries because it helps clarify issues. And then let's move over to higher order functions. Oh, this is sweet. I love higher order functions. In JavaScript, a higher order function is a function that takes one or more function arguments or returns a function as its result. Yeah, these functions, like higher order functions, they enable a powerful functional programming practice. Oh my God. You know, when you're used to higher order functions, there's nothing you cannot do. You know, in JavaScript, they say functions are first-class citizens. And you know, when you work with functions and you learn to compose and then link functions and then chain functions and then work with higher order functions, it becomes incredible. Let's not speak too much English and dive into working with higher order functions. One of the higher order functions we all use almost on a daily basis is the map function. As earlier, I use the map function. Let's say we have numbers 1, 2, 3, 4. And we actually want to multiply each of these numbers in this array by 2. You can see const new numbers is equal to nums.map. And you know what? This map is taking in a higher order function with a parameter of number that returns each number multiplied by 2. Now, if you log your new number on the console, what you're going to get is 2468. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and 4 times 2 is 8. And you can actually abstract this inner function, you can say let's inner func equal to n, then it actually returns n times 2. Then you just abstract it, you remove this, and then put in your inner funct, and everything still works perfectly. And if you want to write this using regular functions, you can actually come here and say function inner funct n and return n times 2, and everything still works perfectly. There's no kablooey, and everything is still working. I love higher order functions. So you can do anything with higher order functions, and let's look at more examples on how higher order functions work. Let's say we have the reduce and the filter function. Let's only look at the reduce function at this moment, and then we'll look at the function composition. And actually we have, let's say we have an array of numbers that has 1, 2, 3, 4, and 5. Then we actually want to add these numbers together. We can say const sum is equal to the array of numbers that reduce. And what they reduce with taking a higher order function, but let's make some abstractions and write this function separately. Then let's say the function, the reduce function we take is equal to inner function, which takes in, yeah, just you can go ahead.
Yeah, you've mentioned this word abstraction again and again, so I don't understand. What does it mean?
Okay, abstraction, we're going to be talking about abstraction when we start writing NodeJs code. When we dive deep into NodeJs, abstraction makes your code cleaner. You try to abstract it, you try to remove pieces of code and then distribute them in various places. Then you bring them together to like make up a functionality. Let's say, for instance, let me try to explain it better. Let me make it inner.js. And inside this inner.js, I will try to abstract this, remove it, and bring it in here. Then we take in n and m. Actually, we return n plus m. Sorry, like this. Then we export this, export inner f. Then we import it here. Import inner something like this. Then inside the reduce function, we just add the inner f, then we add 0. We want it to start from 0. Then we log sum to the console. I will get an error. We run npm init-y because we are working with modules and not common JS. Then we'll come here and we'll specify the type here to be module, and then we'll run it again. Sorry. Yes. Okay. Running test. Yes. Cannot resolve inner JS equals. No, that's JS. And we're getting 15. Yes, because this JS file we're specifying is for module resolution, because the module system was introduced in year 6, and it's very, very tricky in working with module system in the Node.js. We have to specify the file extension for module resolution so that the Node.js engine will know which file it's being imported. So we're importing a JavaScript file, so we have to specify JS. This is an abstraction. We abstracted this function to a different file. Now, every functionality written here does not concern us. We want our code to be clean and minimal. So we have to just import this function and then use it here without any stress. So that is abstraction in simple form. But as we move forward, we explain abstraction in details and how helpful it is. So this is how the reduce function works. And in order, if you don't understand the reduce function very well, let me bring in this function here and then explain it better. Let's say the previous value and the next value, then it returns the previous value plus the next value, starting from 0. So this is how the reduce function works. It will start with 0, which is the previous value. When it starts with 0, the previous value here is 1. Then this will give you 1. Then it will start again. This time around, it has added the previous value to the next one. 0 plus 1 will give you 1. Then we have our previous value here now becomes 1. The next value becomes 2. It gives you 3. Then it comes back. Now we have 3. 3 becomes our previous values. Then, our previous value. Then it takes the previous value, which is 3, then adds it to the next value, which is 4. 3 plus 4 now becomes 7. 7 becomes our previous value, and then our next value becomes 5, right? Am I correct? 0 plus 1, 1 plus 2, 3, 3 plus 4 is 7. And then, sure I'm correct? I know Sabi math again. No? And then 7 becomes our previous value plus 5, which is equal to our answer is supposed to be 50 because the previous value here is 1. Sorry, it's 1. 1 plus 2, which will give us 3, not 0. We were starting at 0, but the previous value actually is 1. Yes, George, you can go ahead.
Yeah, sorry, I'm fine. It was a mistake.
Okay. Actually, we are starting from 0, but our previous value is not 0, it's 1. So we add 1 to 3, and we add 3 to 4, get 7, and all of that, you get to 15. So that's how the reduce function works. And last but not the least, there's no time on our side. Let's quickly discuss recursion. And here, recursion can be very tricky, but then we try not to mess around. We just try to explain what recursion is. Recursion in JavaScript here, it simply refers to the technique where a function calls itself to solve a problem. Like it calls itself repeatedly. It's a powerful concept used to solve problems that can be broken down like into smaller sub-problems. Like normally in programming, when you start coding, they will give you examples on factorial notation, Fibonacci series, and all of that. But I think a very simple example I will give you to better understand recursion is a countdown function. And let's write a countdown function that will make us understand recursion better. Let's say we have a function count down that takes in n, and the first thing in your recursion function is the base case. If you don't specify the base case, your code will run and run and run. No? And if it's running in a production environment or in an environment where the code doesn't stop and the errors doesn't break the code, it will keep running continuously. And you know the resources now, it will waste resources, waste time, waste energy, and nothing will be productive. So you have to specify the base case. And the base case here, what is the base? You always think of the base case as the minimal case, like the least case, I mean the least process where the value will get to. So we want to stop where this value gets to 0. We don't want it to go below, let's say we don't want it to go below 1. We want it to stop at 1. But actually we want it to stop at 0 so that 1 will be included. So we want it to stop at 0. We don't want it to go below 0. So we say if n is less than or equal to 0, you should simply log done. Else, what you're saying, if the value is not if we're counting down and the value is not up to 0, we should keep counting down. So we want to log the value to the console, like log into the console. Then call this function again, but this time around, decrease this number by 1. Now let's try to run this function and see what's happening. Count down 5 and then run it. Yes, and what we are having here, we are having 5, 4, 3, 2, 1, and then done. And let's see what happens if I remove this base case and then run this function again. Can you see what's happening? It's just counting down to negative 10,800 and something. And what maximum cost stack size exceeded, because there is no base case and there's no specific place where the function will stop calling itself, and it keeps calling itself till no base case and it exceeds the cost stack size. So what actually is happening here is this function we initially call itself with the value of what? Count down 5. And then it will push this to the stack, right? Count down 5 and it will push it to the stack. The function, yeah, Josh, you can go ahead.
Yeah, sorry. This count now, is it like is like the limit, right? Where it ends, the way it does not go beyond.
The base case, right?
Yeah, the base case, rather, the base case. Is it base case or base case now?
The base case.
Okay.
Yeah, it's go beyond 0. But when you move this function up, down, it's now count up, not count down again. See what's happening here. Look at the magic recursion. The magic that is happening here. Now, if you run this function, it's now count up 5, 4, 3, 2, 1, and then done. What do you think is happening? Because initially we did it in reverse order, and now we are doing it in a regular order. Now, what's happening is when you call this function with the value of 5, initially when it was a countdown function, it will call 5, remove the function and push it to the stack. Call 4, remove it and push it to the stack. Call 3, remove it and push it to the stack. And while pushing this to the, you need to understand the stack data structure in order to understand recursion. So after pushing it, the last value being pushed to the stack will be the last value to be removed. Now, the last value that will push will be countdown of 1. So when it removes, let's run it again. When it removes 1, remember that there's this console log before this function. So before it gets to call this function, it will log the 1 to the console. When it pops out 1, it pops out 1, and the 1 function, let's say the countdown of 1. What you have here is actually, it will log 1 to the console and then call the countdown of what? 2. This countdown of 2 will do what? We log 2 to the console, and the function will unwind and call the countdown of sorry, never mind the way I speak. It's never a problem though. Countdown of 1 calls the next function, which is the countdown of 2. Then it output 2, then calls the next function, which is the countdown of 3. This output 3, and then 2. But then it's been done in reverse order. You understand? It's been done in reverse on how it's been popped from the stack. So it will count down from 5, 5, 4, 3, 2, 1. Then when it gets to 1, the base case here is 0. Then we got to stop at 0. So the countdown will actually stop. Hello, Josh, you can go on.
Okay, this I understand this logic now. Thanks. This line 6, this counts down is like you're repeating the function name inside. Is it like the syntax of recursions?
Yes, that's how recursion works. You are calling the function to perform the same thing, but it's, as you can see, it's subtracting by 1. So the first time you call this function with n, then it's console, is logged the number, the value 5 on the console, then it's subtracted 5 by 1, logged 4 on the console, subtracted, called itself again, subtracted 4 by 1, logged 3, called itself again, subtracted 3 by 1, logged 2. Then when it gets to 0, where 1 minus 1 will be 0, it will log 1 and then log done on the console, because that is a base case.
Yeah, thanks.
Okay, so in review, we've tried to discuss recursion, but we don't have a much time to go in depth and in advanced problems in recursion. But in review, what we're trying to say is recursion. Before you understand recursion, you have to understand properly and start data structure, and then try to work things around, manipulate things, and then get your head wrapped around recursion. Because if you try to recurse wrongly, your head will recurse and you yourself will recurse and everything will recurse and you will not understand anything. So recursion is a kind of tricky and you have to deal with it properly in order to understand it. So in all what we've said, what we've been saying from beginning, functional programming, prototypal inheritance and all of that. Do you have any questions on anything or you need clarifications? Okay, and if you don't have, we call it a day. And in review, we discussed about prototypal inheritance, functional programming, and how to avoid mutability. And we discussed a little about recursion, functional programming in general. We'll call it a day and we meet again next week. Thank you.
Yeah, thanks. Thanks for the class.
Yeah.